Just start the recording. First caveat, I am having some slight continuing problems with Zoom. If I do freeze at any point, it should reset itself within a few minutes. Don't worry, I will be back. Just as we've all had over the last couple of years with use of Zoom. It has its funny moments, but I will come back as soon as possible if anything does go awry. So today we're going to be covering it's an introductory session to our just quite light touch, getting you used to understanding the differences between R and Python and getting used to the R syntax. As we've got a few more sessions coming up on R, and they'll go into more advanced uses, including simulation, which will be, I believe, next week, and then and that won't be with myself, but with our colleague. And then later in December, I'll be doing an advanced R session where we'll be looking at advanced plotting, distribution fitting, and Shiny apps. So all that to look forward to. But for today, kind of the format of how today's going to run is that I'm going to do an introduction about R and what R, kind of the R programming language, some of its quirks, what its main uses are. And then we're going to use the website that I operate, which has enormous amounts of material on R and introduction to. And so the R for Healthcare website is going to be kind of the essential one for today. So I'm just in case you don't have it, I'm going to first of all pop the link in the chat, so everybody has that. So yeah, so the R for Healthcare website I set up kind of as a repository for all of the training that we've been doing around R. And yeah, this kind of steps through from very, very basic, all the basic concepts of R, up to having some of the advanced R techniques in there as well. So kind of it's a nice one in terms of its persistent repository, go-to place that you can use if you're trying to remember how to do bits in R. Just first of all, first thing, could I ask, we could do a very quick straw poll, as I'm interested to know what your experience in using R is and to kind of get an idea of the breadth. Could I ask everybody to put in the chat their level of using R? So I'd recommend kind of 4 levels, saying whether you don't have any experience, whether it's very basic, so you know you've kind of done maybe a little introduction to R before, intermediate, where you've kind of used it for maybe a project, or if you're perhaps an advanced user of R, just so that we can get an idea of the breadth. Okay, that's great. Thanks, Dan.
Pleasure.
So that's okay. So we've got a real spread of experience here. But that's okay. It's going to be hopefully a good refresher for many people, and for others it'll be, you know, a nice introduction to R and using R. So without further ado, I will bring up the start sharing my screen. Okay. So today's introduction to R. So today we're going to cover kind of, I'm just going to introduce kind of what the different topics are that we're going to cover, and the breadth of the training that's available on the R for Healthcare website. We'll then skip over installing R&R Studio. Hopefully everybody's been able to get it installed or to be able to use RStudio Cloud. And I'll just give a little overview of what R is used for. We'll have a look at the RStudio environment, and then just a few little quirks about getting started with R. So yeah, kind of the aims of the training really are just to familiarize you with the purpose of R and R and RStudio. Get an understanding of the basic data structures and some of the breadth of the functionality in R. To provide you with skills to produce basic visualization, data visualizations, and introduce the use of packages for extending the functionality. Hopefully these will all be very familiar concepts with the excellent training that you've had in Python thus far. So it's all just about the slight differences and understanding how R is that little bit different to Python, but the concepts are very similar. So yeah, we're just going to then look at power and limitations of R, familiarization with the RStudio environment, packages, and the R language itself. So there's a big range of topics that we're going to cover. Don't worry, there's not enormous exercises that go with all of these. What we're going to do is I'm going to do the introductory presentation, and then I'll go through kind of the first few sections with you to look at kind of these different topics and some of the functionality of R. And then I'm going to ask you to work through the different sections on the website to a certain point, and then we'll come back together, go through, see if there's any questions, and then work through the last few together, some of the slightly more advanced functionality. And then there's going to be an exercise which brings together a lot of this functionality, this core functionality and skills that we have here. And then this afternoon, all being well, we will go on to looking at plotting and basic statistics with R, and again, end with an exercise on that. So in terms of the data visualization and statistics, we'll look at a little bit basic plotting, and then also look at a little bit around descriptive statistics and basic t-tests, and maybe even a little linear regression if we have time. So I will just skip through. If you haven't been able to install R, there are instructions on installation, or if you just want a bit of help remembering, if you go to install it on another computer, there are instructions in this presentation on how to install R. So where did R come from? Originally, R comes from a language called S. And believe it or not, S stood for statistics. It was a statistical programming language. And it was developed by John Chambers in 1976 and was developed specifically for statistical computing in the Bell laboratories, which later became Packard-Bell. So R itself was created by these two gentlemen, Ross and Robert. And well, they thought it was funny to name the language partly after themselves and partly taking the play on the name S. So in realistic terms, R has been around for a while in development. They started development in 1992. And then the first stable beta was released in 2000. So why was R created? And have I frozen? Oh. Can you still hear me?
Yep.
Yep. Okay. All right. Okay. It's just my video's gone. So I'll turn that off for the moment. So R was designed primarily for working with vectors and matrices and performing fast calculations across large matrices of data. And it was designed as a functional language, which is why it's different to languages such as C++, Java, and Python, which are object-orientated languages. And in that way, kind of the back end of it was purely designed for this mathematical processing, without looking at handling creating of software or kind of real computer programs as such, with user interfaces. That has actually been kind of overcome in a way now, and with the introduction of Shiny, and there's been this slight move within R to make it a bit more user-friendly in that way. So yeah, it's designed as a script-based language rather than using object orientation. So there's not this such an extent of background operations that are taking place. But it does support parallel processing and multi-threading, so is extremely powerful in that way and can be used in combination with other languages. There's actually, I'll mention that in a minute. Sorry, I'm getting ahead of myself. So let's just have a quick look at the R environment itself. So within RStudio, we get our console in the same way as you have in Spider and many of the Python development environments. So this is where you see your output from your running of your code. You get the script window where you're writing and running your R scripts. There is a variable explorer, which is called the environment, which allows you to see all of your active variables, values, functions, all in one place. There's also the plot display window in the same way as you have in Spider. And in the same way as with Spider, there's the need to set up your working directory to make sure that you're working from the correct place. And I'll go through this in a minute, but there's a couple of, you can either set this as a default working directory in the options. You can set it programmatically within your script, or you can actually set it from the variable explorer window as well. And we'll look at these different options in a moment. So yeah, it's just remembering that setting a working directory and organizing your code is a useful practice. And in a good practice with R is to kind of start your script with setting the working directory programmatically, so you're not having to do it manually every time. And we can do this with a function called setwd, and then giving the folder location. Okay, so I am going to switch over now to the RStudio environment itself. And so down here in the bottom left, we have the console. And this is where we get we can do direct inputs, and it also displays the outputs of our code. Up here in the top left, we have the script window, and this is where we write out our script. On the right-hand side, we've got the environment window here, and here, this is where our variables will be displayed. There is also a shortcut for importing data sets, which you can do from different, from Excel, from text, so as a CSV. There's also options to link it in with SPSS, SAS, and Stata, but we won't be covering any of that in these sessions, mainly because they're not functionality that I heavily use or recommend, particularly for the kinds of analysis that we'll be doing. Just to flag up this little broom here, this is the remove variables button, or clear objects from the workspace. Always a handy one to make sure we know where that is. And so these other tabs, things like the history window, this is a log of everything that's been going on in your environment. And then connections, this is where we can make connections to different different programs and to pipelines into different programs, or very, very advanced are for piping data between different locations. Down in the bottom right here, we have the plots window. And nicely, I think, it makes it very easy to export plots, and that you have the export selection here, and you can save as an image or as a PDF and copy to clipboard. So it's very user-friendly in that way. If we go to the files window here, this allows us to access our folder directories, our actual in our computer locally. And it is here as well in the More tab that we can set our working directory. So here we can set as working directory. So I might want to go in, and Dropbox is where I keep all of my stuff. And so I could go in to my working files and go in and select, so HSMA, and I could select the intro to R and set that as my working directory. And we can see down here that we get in the console, it runs the setwd function, and then as a string, so in quotes, we see the folder location given there. So in terms of other options to be able to set your working directory as well, we can type that directly in. So we could just say set WD, and it gives our tooltip. So it's asking for the directory. We open our quotes, and then I could type in a folder location. Up on the top toolbar here, we have all of our various drop-down menus, which you can explore at your own leisure. But important one here is in Tools, that we have our global options. And here we can go in and set a default working directory for where we want R to go to, just as a standard thing to start out with. So it's up to you kind of how you go about setting your working directories. Right. So I'll just pause there a moment. Are there any questions at all just about kind of the initial basic, and this is the very basic layout of the RStudio environment. There's, as you can see, there's a whole lot more functionality around this as well. But anything about what we've discussed thus far? Okay. Now, like in Python, where you import libraries to extend the functionality of Python, we do the same thing in R. And in R, this is done through installing packages. Now, we can go up to the tools here and click on Install Packages. And this brings up a useful little window to help us to install the packages. And from here, we can simply type in the names of the packages that we want to install. And we can install multiple packages by separating them with a comma or a space. And then it is just a case of, it's always useful to select install all dependencies, and then just select install. And that will run then down here in the console. I think mine's taken my internet's a little bit slow today, so it might just take a minute to run. So that's one way of being able to install packages. The other way is to use the packages tab here. And this gives a list of all of the packages that you have installed currently on your in your RStudio environment. And we can click on install here, and that brings up the same little window. And we can update our packages from here as well. So in some ways, the RStudio environment is a bit of a mix of the Conda environment and the and Spider as well. Is kind of a bit of an all-in-one catch-all environment for package management and for your coding as well. So, and just to say, in the presentation, there's a little reminder of how to go about installing packages as well for yourselves. Now, just lastly, there's a few little conventions which make R different to Python. So Python requires you to make sure that your code is fully indented correctly. It will throw an error if the indents aren't correct. R, however, does not require the use of correct indentations throughout the code. However, programming convention dictates that standard intents are used, and the environment will be set up with default indents. So when you write an if statement, it will indent so that you see where it separates where the code is in the to show that that's within the if statement. If you're creating comments, we use the hash symbol to insert comments, not the hang on, I'm getting confused. LaTeX is percentages, but yeah, we use the hash symbol here to insert comments in the code. And the way that R uses assignment operators is slightly different. So in Python, you simply use the equals sign to assign a variable. In R, it has a slightly broader way of being able to assign variables. So the standard way to assign a variable is to use a left arrow followed by a hyphen. And that is the assignment operator that we're assigning from what is on the right-hand side of the operator to the variable on the left-hand side. The equals sign can be used as it does the same thing as assigning from right to left, but in terms of our conventions, it's poor practice to use this operator. Now, I've just realized that I haven't changed this, and this is the wrong way around. But we can also assign from left to right, which is where it gets a little bit confusing. So we can write what we want to assign on the left-hand side and assign it to the variable on the right-hand side of the operator. And then if you're looking at other people's code, you might see these double arrowed operators appear from time to time. And this is assigning from left to right or right to left, but it's as a global or a parent variable, which means that it's a slightly higher level. And this is only when you get onto advanced uses of R and creating much larger, more complicated projects. Okay, so that's enough of PowerPoint, of slide-based presentations. Let's get on at looking at some R code itself. So first of all, this is the R for Healthcare website, if you haven't already had a look at this. And here we've got, it's set up to make it quite hopefully easy to navigate through the different topics. And at the top, we've got our, it's the basic functionality, plotting, statistics, the exercises, and a link to the GitLab files. And there's also a little bit around web app development with Shiny, but that's for the advanced R session, so don't worry about that today. And so in the basic functionality, in fact, there's last year's HSMA video embedded there if you do want to rewatch anything. But here we have the contents and all of the different topics that we're going to work through this morning. So you can just go through and select a topic, and it will just give a little short tutorial on a particular topic, giving the example inputs and outputs. And so when it comes to the exercises today, I recommend having this, making use of the website to go back through and check the syntax and make sure you're understanding the arguments that are being used if you just need any help at all. Okay, I'm just going to pause there. Any questions or anything at the moment? No? Everybody okay? Great. Right. So I'm going to just go, I'm going to talk through a little bit about the basic data types that are used in R, some the data structures, and just a little bit kind of sequence generation and replication, just to give you an idea of using R and getting used to seeing how how RStudio itself is used. And then I'm gonna let you loose and to work through some more of the topics. So first of all, in terms of data types, R is very similar to Python in that it uses the same data type, basic data types to build up within its code. So we have integers, we have strings, it will take complex numbers, doubles, so floating point numbers with decimal places, Boolean, logical values, and factors, so categorical variables. Now, I've used these names to make them familiar because these are the names that are used in Python. What we'll see now is that R names them slightly differently, just to make it confusing. But they are exactly the same types, same data types. It's just some of the naming conventions are different. So if we want to create, let's create our, I'm going to create a variable now. And so I'm going to create the variable A. Oh, actually, I'm sorry, I apologize, it's small. I meant to zoom in. I'll just zoom in there. Hopefully that's nice and large for everybody to be able to see. So I'm going to create the variable A. And I'm going to assign to the variable A the number 10. And so if I run that, I can now see that down here in the console, it's run that line of code and got the value 10 assigned to the variable A. And hovering on it here, we can actually see that it's in the brackets there. You can see it says, or it might be a little bit small, but it says numeric 56 bytes. The important bit here is numeric, and that is the class that RSI has recognized that value as. Now, without hovering there, we can also check that programmatically using a function called class. And if I do class and put the variable in there, then run that line, I can see in the console that it says it's numeric. Now, if I want to create a string variable, so I'm going to create the variable B and assign to that the string red. If I run that, I see that I get red assigned to B. And if we do class B, this, instead of being called a string, is called a character variable. So there's just these slight differences in the nomenclature to Python, but they are the same. It's the same concepts. If you'd have noticed, I used single quotes here when creating the string or creating this character variable. It doesn't matter whether you use single or double quotes with strings, same as in Python. And also, so when I've been running the code here, I've been leaving the cursor on the line that I'm running and clicking the run button here. That will run the code line by line, and the cursor will move down to the next line. We can also select a whole block of code and click run in the same way as you can in Spider environment. So those are the two most common variable data types that you'll be using, the numeric and character types. But as mentioned, there's also double. So if I create a variable which has decimal points, numbers after the decimal point, and run that, and then look at the class of C, it comes up as numeric. Now that seems confusing because is an integer and a double floating point number the same thing? Kind of. R doesn't treat them that differently. There are some slight quirks to that, but in essence, they're not really seen as different. So the class that they're assigned by R is the same. It's also numeric. Okay. So I mentioned that we can also do factors. So if I want to do create the factor, let's create the factor green. So I take a string, can do it with numeric as well for numerical coding, but we'll do it with a character variable here. And I will assign D to green. So that's a character. And I can convert that to a factor by using the function as factor. And here I've got the variable e, and it's a factor with one level, green. And if you note, it's assigned a numerical code to the factor green 1. So when you're working with factors, it means that they are, while they're categorical variables, they're also treated as numeric, so you can perform numerical operations on them. Now we can also create logical variables, which are done by using true and false. Now with R, the syntax is that the true and false, if fully capitalized, it's treated as a logical value. So if I hover here, in fact, if I do class of F, and we'll see that that's assigned as a logical value. So when we have these different values, we can convert between them as well. So I could actually, instead of for f here, I could make that a string, first of all, and it becomes a character variable. And then I could use the as logical function to convert the character into a logical value. So that's now been converted. And there are these, you can convert to character, to integer, double, logical, numeric, and factor. The way that R uses and does not differentiate between integers and doubles and numerics is confusing, but it will often select the correct data type as it's going through, if it needs to differentiate between an integer or a double. But most commonly, numerical values will be treated simply as the class as numeric. Now here we've just looked at single values, but a big thing that we need to be able to do is to be able to create different structures of data. So let's have a look at different the different data structures that we can have in R. So if I want to create a let me put that differently. The first data type that we were going to look at is a vector, and a vector is a one-dimensional array. Now here I'm going to create a one-dimensional array of the numbers 1 to 5. And I'm using the colon operator to say it's from 1 to 5. And Python uses this similar syntax when you're numerically indexing arrays. So there's a bit of similarity here. And what we get is a vector, very specifically a vector being a one-dimensional array of the numbers 1 to 5. And here, instead of just being a single numeric variable, R has recognized that these are whole numbers and assigned the integer class to them. We can extend a vector by using indexing in the same way as we can in Python. So if I wanted to add the next number, so I want to add number 6 to the 6th position.
Dawn, you're really inaudible.
Yeah, we can't hear you very well.
Okay. Right. So
That was better then when you just said sorry.
is that, yeah, is it a bit better now? I think
Yeah.
My internet is struggling a little bit this morning. I'll leave my video off, so hopefully that will help.
You've gone again, really badly.
Completely.
Can you hear me at all? Testing, testing.
That's fine for the minute.
Yeah,
It's
that's
picked
better.
up again now. Yeah, apologies. Yeah, my internet appears to be a bit slow today. Okay, I'm going to quickly just try and get through basic data structures, and then I think it would be best if everybody gets some hands-on practice, and I'll see if I can if my internet connection picks up a bit. Okay, please do just shout if it drops out again, and I'll pause and see if it just comes back. Okay. So data structures. So I'm going to extend the vector A, and I'm going to put in the 6th position the number 6. And so again, it's the same as with Python. We use square brackets for indexing. And now I get in vector A 6 in that position.
You've gone again.
Sorry.
I don't know what you said. That's inaudible.
Maybe instead of speaking, we could have you just comment what you're doing in R, like as a transcript. I don't know.
Sean, we really can't. Okay.
Is my audio any better now?
Yes.
Yeah. Okay, so just very quickly before it goes again, yeah, I'm going to open the breakout rooms, and if you go through and work through the different topics in the basic functionality and just help each other out, discuss what's happening in the code, and I will be available on Slack. If there are any questions, please just message me on Slack. And if you message in the module 1 channel, that will be the best place. And just go through, we'll work through, take a break about 11 o'clock for 15 minutes. Just have a little break, and we will come back together if we come back at 12 o'clock, I will, if my internet picks up, I'll try and come around the breakout rooms and join, but I don't want to be annoying with no audio and dodgy audio. So I will open the breakout rooms. Hi everybody, and welcome back. Yeah, I hope you've enjoyed getting to grips with R, and that you've been working through the different sections and learning about the different quirks of R as you go along. So I'm guessing everybody's probably at different stages. Could I ask actually everybody just to pop in the chat which number section they've got up to in the basic functionality, just to give me an idea, because we're going to carry on with this this afternoon, and well, just before lunch and after lunch. What I'm going to do now is introduce the exercise that we're going to do, so that you can perhaps focus on the sections which are relevant to the exercise, and perhaps start working between the exercise and the information on the website in the different sections, so that, yeah, you can get used to kind of applying this in more of a kind of practical way. Okay, great. So what I'm going to do, hopefully my internet will hold out for me just to share my screen so that I can just run through the exercises with you. Oh, apologies there, Andrew. That's I will have a look at the subsetting part and get back to you about that. Okay. So I'm just going to share my screen quickly. Right. So here in the exercises section of the R for Healthcare website, we've got the exercise that we're going to be focusing on this afternoon. And under exercise tasks, we've got an exercise on transforming and analyzing mental health data. This is a data set that you might recognize from the introduction to network analysis. Nothing quite like reusing the data sets that I have, the anonymized data sets. So the aim of this is kind of really bring together this use of the different basic functionality in R, to show how you can and to give you practice at really applying these different techniques in a real world situation. And so through the exercise, it goes through, so it's about importing a data set, working with the data in terms of things like calculating lengths of stay, and working with the date time functions in R. Then looking at subsetting and creating tables. And then a little bit of work with for loops and working to create a loop that can go through and calculate different different variables for individual patients in the data set. So there's the outline of what the exercise is, and I've tried to break this down so it's kind of quite it kind of guides you through the different steps that you want to go through in analyzing the data, and particularly for the for loop, what you need to be doing in the for loop itself. So depending on how you're getting on and just how you like to learn anyway, this is kind of very much up to yourselves. It's whether you'd like to continue having a bit more of a look through the materials on the website and working through the different sections, or whether you'd like to look at the exercise and try and focus which sections you're looking at on, and do that by working through the exercise and completing that. Or I've give a solution, which the solution is either at the bottom here or on the exercises page. There's a link to the solution here as well. And that you can, you might like to even look at the solution if you're finding this more difficult, work through the solution, look at the different sections and work out what's happening, and kind of backwards engineer it to understand what's happening. And so that's kind of the task up to 12:30, and then I recommend everybody break for lunch between 12:30 and 1:30. Then come back together at 1:30. So I'll leave you in your breakout rooms, so you can just come straight back into your breakout rooms. And if everybody, once you have completed this first exercise, if you let me know that you've completed the exercise, then I can come in and work to brief you on some of the plotting and statistics, and to start working through that, because I know that everybody's going to be working at slightly different paces here, which is not a problem at all. And the really good thing about doing this, so in next week's HSMA sessions, we got Luca on Wednesday afternoon, who's going to be we got Luca on Wednesday afternoon, who's going to be running through a generic ED model with you. And so the skills that you're learning today, and particularly the basic functionality, they're going to be entirely relevant for Luca's session next week. So rather than kind of pushing too hard to get through to kind of more the plotting and statistics side of things, it's this first section on the basic functionality which will give you a really good basis for that next session. And then for the advanced R sessions, if you fancy diving even deeper into R. So the data set for this exercise is available either in the GitLab, or I posted it for you in the Slack, the module 1 Slack channel, and you can just download it from there. So are there any questions about this afternoon? Anything, or for the rest of the afternoon, anything anybody'd like to ask?
Could you just run through the timings again? Sorry, Sean.
The timings for it. So yeah, so I will send you back into your breakout rooms now, and then everybody break for lunch at 12:30 to 1:30, and then so we'll leave the breakout rooms active over lunch, and you can just come straight back into your breakout rooms. Then once you can work through exercise 1 and the basic functionality this afternoon, after now if you feel ready, or after lunch. And then once you're finished with exercise 1, simply let me know on Slack, and I will come back. Let me know on Slack, and I will come in and discuss with you about the second bit about plotting and statistics. And then, yeah, we'll wrap up by 4:30 at the latest today.
Okay, cool. Thank you.
No problem. Okay, please do just message me on Slack if you'd like me to pop into your group and have a chat with you about anything, or if you've just got a little question, put it on Slack, and I can answer it on there. Otherwise, good luck with the exercise. Hopefully it will kind of make all this a little bit more tangible and real, that you've been learning about this morning, and have fun with it.